Hello students, this is Professor Watts. In this video we are going to be working through an example of the Homework 5 problems. Homework 5 is entitled Monetary Control, and it's going to be covering what we are discussing in mostly Unit 5 with respect to, we'll take a look at the syllabus here. Monetary control, open market operations, policy goals and rules. So those are the relevant lectures, and you'll want to have seen those lectures before you attempt this homework assignment because you want some reference for what we're talking about here. And it also relates to mostly chapter 18 and then a little bit chapter 23 in the textbook. What we are focusing on here is the operations the Fed uses to actually conduct monetary policy. So we're talking about Fed operations with respect to interest rate targeting or money supply targeting or inflation targeting. And we're talking about the Fed taking a look at the variables involved in its dual mandate, so economic growth and unemployment/employment indicators, and then also inflation and monetary indicators, and then making appropriate decisions with regard to either the growth of the money supply or the interest rates or what have you. So first thing we'll do here, OMO1, open market operations. And we'll just think about the operation of monetary policy with respect to changing bank reserves to put upward or downward pressure on interest rates. So it says, reacting to a rising inflation rate, very low unemployment, and the prospect of a, quote, overheated economy, the FOMC, Federal Open Market Committee, decides to raise interest rates by 50 basis points. Okay, so we're looking here at a pre-existing equilibrium in the market for bank reserves, and this would be the market to borrow/lend bank reserves, federal funds. And of course, we have an upward sloping supply for bank reserves, which would be excess reserves that banks hold. And you'll recall from previous discussions that if banks have excess reserves, well, they could invest them in any number of investment vehicles, particularly loans. And the federal funds market just represents the kind of short, safe lending. These are usually overnight. Low interest, very safe, very liquid. You get the money back the next day with a little bit of interest. So we can think about the level of the federal funds rate and whether it's going up or down as kind of a barometer of broader credit markets. And that's certainly how the FOMC wants us to think about it. So we've got the interest rate on the price axis and then the quantity per day in billions for bank reserves in this federal funds market. All right, so here's what the problems are going to ask us to do, and we'll fill out all the answers in these little yellow cells over here, which have I have data validation rules on these cells, so you can't enter inappropriate responses here. Now you can be wrong, so you got to make sure you get the solutions right. So it says find the initial equilibrium federal funds interest rate, FFR, and daily quantity of reserves lent borrowed. Well, that's going to be at this intersection of supply and demand right here, so we can follow this green dotted line over to the interest rate axis, and these are in all the responses are going to be in 50 basis point or 1/2 percentage point intervals, so it's between 2 and 3, so that's going to be 2.5%. So we'll type that in for the equilibrium rate, and then the quantity will follow down here at the equilibrium. We see that's 5 billion, so we'll just enter 5 there. Okay, now Part B says indicate which open market operation, open market purchases or open market sales, the New York Fed system open market account would engage in to push the federal funds rate in the desired direction. Well, up here we had seen that the FOMC decides to raise interest rates by 50 basis points. What we'd be looking for is a leftward shift in the supply curve of reserves. So we'd be looking for the Fed to drain some reserves. The Fed wants to take reserves away from banks. So what does the Fed want to do? Does it want to buy securities from banks or sell securities to banks? Well, which one of those options would involve the banks handing over reserves to the Fed? It seems that if the Fed sold treasury bills to banks, the banks would pay for them with reserves, right? And those reserves would go to the Fed and be extinguished. So we're looking for open market sales. And if you're kind of fuzzy on the whole issue of open market sales and purchases, I'll just invite you to go back to that lecture on monetary control and review that. So we're looking for open market sales. Okay, and then the next part of the question says indicate whether the Fed's actions shifts the demand or supply for reserves and in which direction. So we're going to be shifting supply, as I just indicated, to the left. And there's my proper shift, so I can now get rid of my drawing. Okay, so we've got the purple supply curve as the shift. Demand, is that going to influence demand? Well, no, it's just a supply action, right? So no change in demand. And now we can see equilibrium 2, the orange dotted lines with the interest rate at 3% and the quantity per day at 4 billion. So let's indicate those for equilibrium 2, 3%, 4 billion. And then just it says indicate the final equilibrium, which we just did, and then indicate the resulting change for the federal funds rate and reserve loans. The federal funds rate, of course, increased as desired, and the daily quantity, of course, would have to decrease. Okay, so that's just a supply and demand framework applied to the reserves market. Pretty straightforward. Let's practice one more of those. Open market operations 2. Reacting to a decline in consumer spending and inflation rates well below their target, the FOMC decides to cut interest rates by 50 basis points. A, find the initial equilibrium for the FFR and daily quantity of reserves. So we are at an interest rate again here of 2.5 and 5, same equilibrium. You won't always see the same starting point in the actual assignment. Quantity of 4 billion, type of open market operation. Now, we're looking for an interest rate cut. All right, so I'll go ahead and jump down to supply. I know I want to shift the supply curve to the right. And so the Fed is adding reserves to the banking system. How is the Fed adding reserves? By buying something, right? And then giving those reserves in payment. So the Fed is, of course, going to be doing open market purchases, buying treasury bills from the primary dealer network. Is this a demand or supply shifter? It's a supply shifter, right? So there's no change in demand once again. And now we can see the orange dotted equilibrium point. Interest rates have dropped to 2%, the Fed funds rate, and the quantity of reserves lent and borrowed has risen to 6 billion, meaning that as intended, the federal funds rate has declined and the quantity of reserves borrowed / lent has increased. All right, let's jump over to interest on excess reserves. Now, if you'll recall from the lecture, I talked about a situation where the Fed has pushed the quantity of excess reserves in the banking system so far to the right, or increased it so much that normal open market operations mechanism of kind of doing the little hokey pokey, shifting that supply curve a little bit to the left or right, no longer impacts the short-term interest rate, the federal funds rate. So now we have to do something different. So let's read the scenario here. It says, through quantitative easing, QE, technically known as large-scale asset purchases, the FOMC has increased the supply of bank reserves well beyond the downward sloping range of bank reserves demand curve. And here you see I've only pushed it a little bit, only 4 billion past. In reality, this is going like $1 trillion past maybe the point where the downward sloping demand curve for reserves bottoms out at 0. In reality, the distance between where the demand curve intersects the horizontal and the supply of reserves is actually much, much larger than this. I have some constraints in the scope of my graphing space here. So find the initial equilibrium federal funds interest rate target and quantity of federal funds lent borrowed from the graph. Well, the price is going to be 0, right? Because the demand curve is bottomed out. So we're at this, what is known as the 0 lower bound for interest rates, and the supply here is sitting at 14 billion at that price of 0. B, can the Fed influence the federal funds rate through normal open market operations in this scenario? And we have to be kind of careful here and parse this. What I mean by normal is small. So if we just did a small shift of the supply curve to the left, right? If we did something like this, would that put any upward pressure on the federal funds rate? Well, no, because we'd have to keep, we've got a long way to go before we even get to the sloped portion of the demand curve. So the answer there is, of course, no. Fed's influence. No influence through normal, which again means small open market operations. So we're going to have to do something different. And what the Fed is going to do differently, as hopefully you'll recall from the lecture, is instituting interest on excess reserves, which, as I explained in the lecture, acts as a floor on the federal funds rate. So let's adjust the interest on excess reserves rate to achieve a 50 basis point increase in the federal funds rate. That is 50 basis points above the market equilibrium rate. Well, the market equilibrium, as we just discovered, was 0. So we want to set the interest on reserves 50 basis points above that. And notice what that does now. That causes the demand curve to bend at that 50 basis points line. So now the demand curve for reserves becomes perfectly elastic at any federal funds rate below 50 basis points. And again, the reason for this, I won't go into this in detail, but the rationale hopefully is pretty straightforward by now. If the Fed is paying these banks 50 basis points just to sit on reserves, excess reserves, you wouldn't lend them to another bank for any price below that, would you? No, in fact, you'd want to borrow. You'd want to borrow excess reserves. So let's say the federal funds rate was 40 basis points. Well, you could go borrow federal funds at 40 basis points, park them in your own reserve account, and earn 50 basis points through the IOER rate. So that arbitrage would quickly push the federal funds rate up to 50 basis points, and which is indeed exactly what it does, and that's why we see this demand curve level off here at the 50 basis points rate. If we wanted to keep pushing that higher, then what would the Fed do? Well, they would just keep raising the floor, and as you can see, if you indicate the proper rate over here, that's what will happen. And in the homework, I'll just ask you to dial in the IOER rate exactly where the Fed wants it. All right, so this is a big part of how monetary control works in the environment of a post-quantitative easing environment where there's been a tremendous increase in excess reserves, as we know first began happening in 2008. Okay, and another part of how the Fed currently operates, or at least post-2008, is the repo market, repo/reverse repo. So let's think about a little bit of repo operations here in the homework as well. In a repurchase agreement, repo, a bank borrows reserves, effectively borrows reserves, by selling treasury bills to another bank and then buying them back with interest immediately, usually the next day, very shortly thereafter. In a reverse repo, what we have is the Fed borrowing reserves by selling treasury bills with the agreement that the counterparty, a bank, will sell them back to the Fed, usually again the next day. Okay, so now we want to think about how the Fed can use repos or reverse repos to influence interest rates in the interbank reserves lending markets. A, find the initial equilibrium federal funds interest rate and daily quantity of reserves lent and borrowed. And we're back to just our normal upward sloping supply, downward sloping demand. So we'll just find the equilibrium here, which again occurs at 2.5% interest rate, 5 billion in reserves. Remember, that might be different in the homework, so make sure you reference the diagram and find the actual equilibrium. Do repo/reverse repo actions by the Fed affect the supply or demand for reserves? Well, remember, again, the Fed could be borrowing those reserves from banks through reverse repos or lending those reserves to banks through normal repos. So the Fed is going to be moving that supply curve either to the left or to the right. Right, and if you think about, what does the Fed do? The Fed can print money, right? The Fed can print money or the Fed can take money away. The Fed acts on the supply of money fundamentally. C, indicate the type of repo the Fed would use to put upward pressure on the federal funds rate. Right, so we want to shift the supply curve to the left, don't we? Let's go ahead and do that now. And we know that demand is not operable here, so we'll just indicate that's no change. So what kind of repo actions would the Fed use to put upward pressure on the reserves interest rate? Well, they'd have to pull some reserves away from this market, right? The Fed would have to take reserves away from banks. Through open market operations, we know that would be done through open market sales. What's the equivalent to that functionally with respect to repos? Well, that would be reverse repos. That would be where the Fed is engaging in repos from the bank. So the Fed is borrowing reserves from banks by selling them treasury bills with the agreement then to buy them back shortly thereafter. So we're looking at a reverse repo here. And as a result of this simple shift, we've increased the interest rate 50 basis points. So we'll type that new interest federal funds rate in at 3%, and the quantity borrowed lent has dropped to 4 billion per day. Okay, now let's click over to the sheet entitled Friedman Rule, and we'll think about some monetary frameworks here for the remainder of this assignment. And it says in the box, assume the Fed adopts a Friedman-style money growth rule. And again, I explained this in the lecture entitled Policy Goals and Rules. And we have delta M, percent delta M set at 3% per year. For each scenario, insert the values provided in the appropriate cells and then solve for the remaining value. And you'll notice you recognize our old standby, the equation of exchange, which right now, of course, we remember the basic version of this as M times V equals P times Y. Money times velocity equals the price level times real output. We are working with it though in this what we call the dynamic version of the equation, where we think about the percent delta growth in M plus the percent delta growth in V equaling the percent delta growth in P plus the percent delta change in Y, right? So we might describe this as money growth plus velocity growth. What do we call the percent change in the price level? The inflation rate equals inflation. And then the change in the real GDP, we'd call that real growth. So money growth plus velocity growth equals inflation plus real growth. This is how we're thinking about the impact of this monetary policy framework. Okay, so let's plug in the values. Now, we said that we're dealing with a 3% growth rule. So I'm just going to go ahead and plug that in across the board. And what we want to do here is see what would the impact of that be based on various scenarios where we have velocity moving up and down, inflation moving up and down, and real growth moving up and down, right? Why does real growth move up and down? Well, it happens through supply or demand shocks that buffet the economy, and that's something we'll talk about next week's lectures. What about velocity? Velocity happens through autonomous changes in people's spending or savings habits, right? And then inflation usually would be the residual of those real factors and demand factors that are driving changes in the GDP and velocity variables. So let's run with a scenario, and then we'll see how we want to think about it. Velocity grows at 2%. Positive supply side slash real factor conditions generate 5% real growth in GDP. Okay, so now we want to derive what the inflation rate would have to be. Well, we have a total of 5% growth over here on the M times V side. We need a total of 5% growth over here on the real growth and inflation side, and 5 of that 5% is taken up by real growth, meaning what? There's nothing left for inflation, so inflation would have to equal 0%. Okay, now how do we want to think about this? Well, it looks like the rule's working pretty well. Lots of real growth, no inflation. Money growth rule is acceptable, and so I want to summarize that from among these 6 choices. What does it look like? Well, it looks like growth. Is it inflationary? No. Is it deflationary? No. It's just non-inflationary growth. There we go. So like we put a thumbs up on that. Looks good. Okay, but let's look at maybe some scenarios where the money growth rule doesn't give us what we want or doesn't adapt so well to the conditions that we're in. So part B says velocity declines at a minus 5% rate, and the negative wealth shocks drive inflation to -1. So velocity is dropping, and that's going to pull inflation rate down. Now let's solve for real growth. Well, we've got a total of -2, right? And if you like, you can write down the total over here just to check the math. I got a -2 over here, means I got to have a -2 over here. -1 of that -2 is an inflation, meaning the other -1 has to be in the form of declining real growth. So now what do I have? I have a recession because real growth is negative, and I have deflation because inflation's below 0. So we're going to call that a deflationary recession, and that's maybe not the best possible outcome. And it's maybe incumbent on the Fed now to go ahead and let money growth get larger to offset the decline in velocity and to keep inflation above 0, if the Fed has indicated preference for a positive inflation target, which indeed it has for us. And the past decade or so, the Fed has been very explicit about this, but even before that, the Fed has generally favored a positive inflation rate for reasons which I discuss in the lecture. So maybe not a ideal outcome, because the money growth rule is tying the Fed's hands and preventing it from letting money grow more to offset these other factors that are occurring. Okay, then finally, part C, it says credit expansion drives velocity growth to 8%. So now we got a big increase in spending driven by a credit boom and inflation also following that up to 6%. So my total now is 11, 3 plus 8. So that means the total over here has to be 11. 6 of the 11 is inflation. The remaining 5 is in real growth. Okay, now 5% real growth looks good, but 6% inflation would be well above any central bank's target or preferred level. So what are we going to call this? That looks like maybe an inflationary boom, right? Now, how do I distinguish between inflationary growth and inflationary boom? It is probably ultimately a judgment call. I'm going to call this an inflationary boom because I didn't have any indication that it was some positive supply shocks that was driving the growth rate up, right? If I had something that said like there's amazing new technological advances that it cause a sustainable increase in potential output growth from 3 to 5%, okay, then maybe it's not an overheated economy or a boom. But usually, along with that, you wouldn't see an increase in inflation, right? So usually if you have a pretty steep increase in inflation and a pretty steep increase in real growth, I'm going to call that an inflationary boom. And once again, money growth maybe is kind of ineffective in dealing with this. We might want money growth to be lower, maybe even temporarily negative, to head off this high inflation. But it starts to get pretty complicated here, because now we want to think about, well, what are the factors leading up to the credit boom? Part of that might be money growth in the Fed. Part of it might be a slew of other factors in the economy. Okay, let's move on to our final worksheet here, which is the Taylor Rule. And again, I discussed this in that policy goals and rules lecture. So hopefully you've just watched that and you're very familiar with how the Taylor Rule works. So I'm not going to walk through the entire operation of the Taylor Rule again, but this time I'll just have us, we'll observe what happens to the targeted rate for the policy interest rate, which is over here as I, based on changes to actual GDP relative to target, and then actual inflation relative to target, actual GDP percent growth, I should say, relative to target. So I've got 4 different scenarios. We've got an actual GDP and inflation rate given. We'll plug those in. We'll see what the Taylor Rule equation kicks out as the recommended policy rate, and we'll slap a description on that. Okay, we'll see kind of how the Taylor Rule reacts, and we'll see if there's any limitations to the Taylor Rule. So scenario A. Okay, so we have actual GDP growth rate at 3% and the inflation rate at 0%. So let's go ahead and plug these in. Notice, for starters, I just reset this. The baseline, I set the actual GDP growth to 3%. So potential GDP is 3. There's no output gap. And so the output gap component of the Taylor Rule is not going to contribute, because it works out to 0 in the equation. And then also I set inflation to 2%. So there's no inflation gap. So that works out to 0 as well. So the Taylor Rule baseline is 4%, which again, that's just the Fisher equation. I equals R plus pi. Real interest rate, real short-term interest rate estimated at 2%, actual inflation at 2%, right? But as you'll see, when we start getting deviations from target for potential GDP growth and inflation, these factors will come alive, so to speak, and then they will start to push the policy rule around. So we'll keep actual GDP growth at 3% for scenario A, and then set the inflation rate to 0%. And you'll see now that we have an inflation gap of minus 2%. Inflation is 2% below target, so a minus 2% inflation gap multiplied by the weight of 0.5, so that's going to subtract 1 point, 100 basis points from the policy rule. And then, because inflation itself has fallen to 0, that's going to subtract 2 more points. So the policy recommendation is now a 1% interest rate, so we'll plug that in there. And how should we describe that? We have normal growth with no inflation. I'm going to call that non-inflationary growth. Right? So that's pretty straightforward. Scenario B, let's check this one out. We have 5% real growth and 5% inflation. So let's plug those values in. Okay, so wow, that brings my recommended policy rule very high. Why? Well, the inflation component alone is going to increase the policy rate by 1.5 times the inflation gap. The inflation gap is 3 points. So multiply that by 0.5, and that gets you 1.5 points of increase. And then also rather add the actual inflation rate in. So that alone is going to cause a hefty hike in the policy rate. And then the 2-point output gap, which we see here, multiplied by its weight of 0.5, that's going to tack on another point to the Taylor Rule recommendation for the policy rate. So we've got a pretty hefty policy rate increase here. We want to get that rate boosted so we can cause an increase in the real interest rate and tamp down on the excessive borrowing, lending, and spending that's going on with GDP growth and inflation both being so high. So let's type the recommended policy rate in there, 9.5, and then how shall we describe that? Well, we've got growth above potential, and we've got high inflation. So I'm going to call that an inflationary boom, overheated economy. Might think, well, wouldn't that just be inflationary growth? Well, it is growth, but it's growth above potential, and that's the key. We said potential GDP growth is 3%. We didn't recognize that maybe there's some kind of positive supply shock that's taking potential growth rate higher. So as long as we're saying potential growth is still 3, this would be over and above that, so it would be overheating the economy with excessive growth and inflation. Okay, scenario C, minus 2% for GDP growth. So we're in a recession environment now, and then 4% inflation, looks like an inflationary recession. And we're going to pull the interest rate down accordingly but not as low as we would have been without the inflation. So we still have a pretty big positive inflation gap, even though we have also a pretty big negative output gap. So we're going to plug the policy recommendation in, 4.5%, and then we're going to call this an inflationary recession. Okay, finally, scenario D, we have a minus 5% GDP growth rate and a deflation rate, minus 1%. So here you can start to see, as you recall from the lecture video, we're now in negative territory for the policy rate, which, as I mentioned, it's possible, but the Fed doesn't want to do that and wouldn't be very popular in the US economy. So the Taylor rule can't really be adopted here because we're past the zero lower bound for the short-term nominal interest rate. So policy rate can't be adopted per the rule. Nonetheless, we would call this a deflationary recession. Okay, so there you see how the Taylor rule works in practice. You'll have a similar set of scenarios to work through in the homework, and you should be all set.